Okay, so how's everyone doing today?
Good, how are you?
Good. How did it go with your games assignment? Some of you were happy with the games you were able to make? Happy-ish. So one good thing about this exercise is you get a first crack at designing a game before later in the course, actually it'll be assignment 8, you'll be designing another game, and it will be a fully, what you really think of as a video game. So with graphics, with music, soundtrack, with sound effects, animation, whatever you want, mouse input, keyboard input, anything that you like. And so what I want you to think about, even now, start thinking about what kind of game you would like to make. So that when that assignment comes around, and once we've learned how to use all of the tools that allow you to make games like this, you don't spend a whole week thinking about what you want to make and then not actually have time to make it. So start thinking about that now. And a game is fairly loosely interpreted here. So this doesn't have to be a game for like a gamer. It could be a game for a child, or it could be some kind of educational game, a simulation game, whatever. But it has to have more or less all the same components that this one had. Elements of timing, and it'll have to have sound and soundtracks and other things. But start thinking about that now. Okay, so there was a question there. Yeah. Yeah, we'll grab soundtracks and sound effects from places that have these things available, licensed under some Creative Commons license. So we won't pirate anything, but there is plenty of this stuff available. So certainly short loops of soundtracks and sound effects are freely available. You can even record your own if you want. Okay, so does anybody have any questions for me about anything? Yeah? I will show some of the games. When we start, I'll show some of the games the students and I made last year to maybe give you some ideas. And then usually after the assignment is submitted and marked, the TAs pick some of their favorite games, and they get distributed in a zip file for people to play if they want. And as well, one of the tutorials will be devoted to people showing off their games and letting people play it as well. So if you're really into it, there's some motivation to really show off there. And I know a good fraction of you are in the game stream, so hopefully you're actually interested in making games. Otherwise, maybe you should consider another stream. Okay. Any other questions? The other good thing about making a game is, a lot of you are in the game stream. If after making your first game you decide you really don't like it, well, you can switch out of the game stream already in the first semester. So that's a good thing too. All right, so last class we had talked about this difference between two things being equal versus two things being identical. And then we had started to look at this notion of object-oriented programming, where you define things in terms of classes of objects, and then once you define a certain class of objects, then you can define instances of those objects. So here, for example, we had defined a class called person, and we can say, this represents a person with a first name and last name. And pretty much at a minimum, when you define a class of objects this way, it should have an init method, and it's a special method. You can recognize these because they have 2 underscores before their name and after their name. And all of these object methods take a first argument called self, and then whatever real arguments you want them to have. And self really refers to this instance of the object, so this person. And you can set properties of self. Like here we set first name, and here we set last name. And right, the way you use that is, now that I've done this, I can define a person whose first name is Pat and whose last name is Morin. So if I look at this new person Pat that I've defined, Python tells me that it is a person object and it's at some weird string there. In fact, that weird string is actually a memory location. So it tells me where in memory that person is. That's not something that's particularly useful to know precisely where it is in memory, but it can be useful for debugging. So let's define another person. Let's say Jeff. And now we've defined another person named Jeff. And nice thing about this is, well, we can see Pat and we can see Jeff. And it says for both of them we can see at which memory locations they're stored at. So Pat is stored at this long memory location. The important thing is the last couple of digits there. And Jeff is stored at this other memory location. And they're actually identical up to the last couple of digits. So, do you think that Pat equals Jeff? No. False. Do you think that Pat is Jeff? Are they identical? Okay. So what's the clue that they're not identical, other than the fact that they're not equal? Yeah? Yeah. So what being identical means that they're stored at the same memory location. And here we can see this clearly now, that Pat and Jeff are actually stored at 2 different memory locations. So the variable named Pat, so the picture of that looks like this. There is a variable named Pat, we think of as a box, and it points to some memory location, which starts at, well, we had it there, something, something, and ends with a 10. This is the memory location. And over there, there's a person whose first name is equal to Pat, and whose last name is equal to Jeff. And then there's a variable called Jeff, which points to a different memory location ending with a D0. And there's, at that memory location is a completely different person object. Jeff, and last name equals Erickson. Okay, so they are different. They're not identical. Now, what can you do with these objects? Well, Pat has properties. One of those properties is a first name. It's the string Pat. One of those properties is the last name. It's the string Morin. And Jeff has properties also. Those are properties that we set in here. And in this init method. And one of the things, unfortunately, that you'll find is that people who do programming languages love to make up different names for the same thing. So they're sort of the opposite of mathematicians. Mathematicians like to pick a name that applies to a whole bunch of different things. Programming language people do exactly the opposite. They introduce the same concept in different languages and they call it different names. So in Python, these things like first name and last name, they're called properties. Properties of an object. And if you've done Java, you may have heard of these things as being called instance variables or instance data. So there's another name for the same concept. And yeah, so instance variables is a typical name for these things. All right, so now in Python, unlike in some other languages, there's nothing super special about these. So anybody can look at them just as we've done here. We've looked at Jeff's first name, we've looked at Jeff's last name. We can even set them. So we can change Jeff's first name. Change it to Pat. We can change Jeff's last name. Change it to Morin. In our picture, that has us overwriting these properties here. This was now set to Pat, and this was now set to Morin. So, now, after doing that, do you think that Jeff and Pat are equal? So who thinks yes? Put up your hand if you think yes. Okay, a few people. And put up your hand if you think no. Okay, a few more people. So the no's have it. Jeff and Pat are not equal. Can someone suggest a reason why? I mean, they both have the same first name and they both have the same last name. So why aren't they equal? Yep.
Because the first object is called dot whatever, and then the second object is called Jeff. So if you change the
Okay, so the suggestion is that, well, the first one is called Pat and the second one is called Jeff. So that those two things are not equal. What if I do something like this? Derek equals Pat. Now are Derek and Pat equal? Yeah. Yes. So the name of the variable doesn't seem to matter. It's not because one is called Pat, the other is called Jeff. Yep. So they're still at different memory locations. So, so Jeff is still not Pat. So they're still not identical. What about Derek and Pat, on the other hand? They're identical. And that's because this assignment, when we set Derek equal to Pat, so remember how assignment works. So I have, let's go back to black. We created this variable called Derek, and we set it equal to Pat, which means it gets the same value as Pat, so it points to the same memory location as Pat. That's this object up here. So Derek and Pat, they are the same thing. In fact, if we look at Derek, it's a person object at this memory location that finishes with a 10, and if we look at Pat, it's a person object at the same memory location. So they really are identical. And now Jeff is off on his own somewhere else at a different location. So somehow we're not seeing a big difference here between two things being equal and two things being identical. Basically, right now, two persons are equal if they're identical. And that's because we never really defined what it means for a person to be equal to another person. So there's all kinds of philosophical things you can say here. All people are created equal, but that's not useful for what we're trying to do here. So if we want to say what it means for two people to be equal, then we need to define what that means. And we do that by defining a method called underscore underscore equal, self, other. So this is a method that takes, the usual self argument, this object, and a second argument, the other object, and should return true if we would like to treat these two objects as being equal. So what's a reasonable definition of two persons being equal if the only thing persons have is a first name and last name? Yeah. Yeah. So we could say what we want to return is self.firstname equals other.firstname and self.lastname equals other.lastname. And I hate code that's more than 80 characters wide, so I'll spread that across 2 lines. Okay, so that now defines what it means for two persons to be equal. Yeah?
Well, if a different class has an unreasonable amount of properties.
Well, then either it's going to take a long time to test if two things are equal, or you pick some subset of the properties as the ones that matter for testing equality. But yeah, there's that issue. I mean, there's some other tricks like hashing to speed up those cases, but arrays, for instance, have a huge number of properties. I mean, they have an unbounded number of properties. And to test if two arrays or two lists are equal, you really go through those lists, comparing all the elements. So it just takes time in those cases. Okay? So let's try with this new version of these things. Okay? So here's Pat, here's Jeff. They're at different memory locations now, but they're still different from each other. So now, if we check, is Pat equal to Jeff, then we get true, because they have the same first name and the same last name. And so this operator here, equals, the way it gets implemented in Python is it looks at the class that this left-hand side belongs to. In this case, it's the person class, and it calls its equal method. So this is really equivalent to code that is much uglier and looks like this. So this double equal method is basically just a nicer looking version of calling this equal method here. Okay. Now, before that, we didn't have an equal method defined, and so what gets used then is just the default equal method for objects, where two things are equal if and only if they're identical. So before these would not have been treated as equal because they're at different memory locations. They're not identical. But now we've fixed that so that as long as their first names and last names match, we treat them as equal. Now, is Pat Jeff? No. That doesn't change because they're still at different memory locations. They're not the same object. Okay? So there's this special method called underscore underscore equal that you define, or EQ, that you define if you want to be able to change what it means for two objects to be equal. There are other special methods. Here's another one that's particularly handy. So you get tired after a while when you're debugging And every time you look at one of your objects, you see something like this. And what happens if I try and turn it to a string? I get the same thing again, so not particularly useful. So it's actually one of the most common methods to implement is the underscore str method, which takes only the one argument and returns a string representation of this thing. So maybe a nice string representation would be something that indicates this is a person and their first name and their last name. So print person, so something that tells you this is a person and their first name and last name. So now, if I convert Pat to a string, then I get a nice looking string, a nice representation of this that at least tells me something useful about the contents of the object. And there's another one of these, well, there's a whole bunch of these useful built-in methods, and another one is the representation method, which what it's supposed to do is return a string that looks like the Python code you would use to create this object. Yeah?
Is it always better to use return rather than print?
Oh, yes. Print is a completely different thing. So print just puts something onto the console, but doesn't return anything. So you can't assign a print statement to something. So you really want to return in this case. And you're supposed to return the string, which is this thing, because sometimes you want to do things like this. S is the string that's given by Pat, and if you had just printed person Pat Moran, you wouldn't. This wouldn't work at all. Okay. So this representation method is supposed to make a string which looks like Python code that would create this object. So how would you create this person? Well, how did we create this person? Yeah.
Call by initials thing?
Call.
Initials method?
Well, how did we create this person here? Yeah. So we called the class, basically, right? And we specified the first name and last name. So that's the string we want to return. So we want to do something like person. Let's try that. So this should return a string that looks like we're creating a person, right? That's the way we create a person, is by calling this class with two arguments, the first name and the last name. And I want those first name and last name to look like I made strings out of them. So I want them to look like they are, like strings. We can check that out. And now, when I look at this person, like this is just the view. I didn't print it here. I didn't convert it to a string. I just asked Python to show it to me. And instead of telling me that this is a person object at this memory location, it actually gives me some code that says, well, it's a person that was created this way. So this is code you could cut and paste and put into a Python program. On the other hand, if I ask to print it, it converts it to a string and prints that string representation. Okay. So there's a whole bunch of these methods, so-called special or magic methods in Python. We've seen sort of the important ones. Init is the most critical. Every object has to have an init method that its job is to take some initializing arguments and set those as variables for this object and do any other work that you should do. We have seen representation and string, and we've seen equal. And along with equal is a whole bunch of comparison operators. So less than or equal to, not equal to, greater than, and greater than or equal to. If you have objects where you would like to be able to compare and say, is one less than the other or greater than the other, well, you would define these things. So for persons, for example, you might like to say that the way you compare two persons is by alphabetically comparing the strings that are their last names. If they're the same, then you compare the strings that are their first names. If they're the same, then they're equal. But otherwise, you implement all of these things. Okay? And there's a whole bunch more of these that you can look at when you need to, and we'll revisit some of these later. So these are the special methods. But you're not restricted to defining so-called special methods. You can do any method you like. So for example, I can define a method called prettyprint that actually prints this thing instead of returning anything. And maybe it does something like put some cute curly braces, and prints the string representation of this thing. So that actually prints it. And you asked the question about, is it better to return or to print? Well, it's just different, because if I try and assign this, let's look at S now. S is not anything. In fact, S is the special object called none, which means not really assigned a value. All right. All right, so now we sort of know how to create these classes. The question is, why would we want to do this? And the answer is, well, classes are just, in many applications, they're useful for modeling things. And so I've done this long enough now that I fall into the terminology. They're useful for modeling objects, but where object means just about anything that might occur in your application. The way you pick them out is you think of these verbs, is-a and has-a, or not verbs, but these phrases. So for example, Pat is a person. So if you find yourself saying things like this, Jeff is a person. Alex is a person. So if in your application you think of, something is a something else, so, Pat's a person, Jeff is a person, and Alex is a person, then that suggests that person is a certain class of objects and it should be defined as a class. On the other hand, there's these has-a relations, where you say things like, Pat has a last name. Pat has a first name. In general, every person has a last name. Every person has a first name. And so you see these two sort of natural phrases that pop out of things, is-a and has-a. When you see is-a, Well, that says you want to make person into a class, like we've done here. When you see has a, that says that you want to make last name and first name, in this example, into properties of a class. In this case, the class is the person class, because we've already determined that Pat is a person, or Jeff is a person, and Alex is a person. And so since Pat, like most people, has a first name and a last name, then most persons should have a first name and a last name. So that's the sort of way you use these things. All right, that's all rather abstract. So now we'll do something that we should, it's always good to do, which is to take some new piece of programming language or new programming style that you've learned and apply it to some program that you've written before to make it better, nicer, more readable. So I think if we go back to, we have a quiz game. Let's copy that into the current directory. So remember, we had this quiz game, and that we developed two classes ago that read a bunch of stuff from a bunch of questions from an input file, and then asked them. We actually got pretty far in making this game. So could we maybe make this code a bit nicer or a bit more readable if we use objects? So in a quiz game like this, are there any objects that stand out? Yeah. Yeah. So if you look at, if you have code like this, and you're trying to ask, well, are there any objects that stand out? Well, then you should usually look at some of the variables in your code and ask what they are. So P is a range, so it's actually an array. Diff is an integer, so there's already integers. But here we have Q. Q is a question. I mean, the most natural way to think of Q, in fact, the way we talked about it when developing it, was saying Q is a question. But in fact, in this program, Q ends up being an array, because the way we represented a question was as an array. The first element of the array was, the 0th element of the array was the actual text of the question. Then the next 4 values were possible answers, and then the 5th value was the category, and the 6th value was the difficulty. So not particularly intuitive, right? Not a great, I mean, it would be nicer if we could call these things by names rather than, question at 0, question at 1, question at 2, and so on. So what does a question have? Well, I think we've just said it. A question has an actual text of the question. What else does it have? Yeah. So a question also has answers. What else does a question have? Yeah. It has a difficulty. And the final thing that a question has? Yep. Not always. Yep. Category. So those are the things. We have them actually listed up here. We wrote this down because we didn't want to forget what was supposed to be in all these array positions. But it would be nicer, for example, to say, let's define a class called question. And when we initialize a question, we'll take we'll call it the text of the question, which is the words that the string that's displayed as the question itself. We'll take the answers. We'll take the category, and we'll take the difficulty. All of those things as arguments, and we'll save them. So self.text equals text, self.answers equals answers. And mostly we'll just save them as they are. The one that we'll be a little bit careful about is this difficulty. We want to make sure we store that as an integer, because it may come into us as a string, so we'll make sure that we keep it as an integer so we can, so we don't get any surprises. Okay, so we've determined that there is this class of things called questions. So we've defined that class, and we figured out what the properties of a question are, because a question has a text, it has an answer, it has answers, it has a category, and it has a difficulty. Is there anything else that a question has? Maybe that comes later? Yeah. We could store the question, we could store points with it, but that's sort of a function of the difficulty, and so it's not clear if we should store that or let somebody else figure out how many points it's worth based on the difficulty. That's debatable. Anything? What's that?
Correct answer.
A correct answer. Okay. It has a correct answer. So right now, what's the correct answer? If we were just to look at, if we were just to create one of these questions using the data that comes out of the file, what would the correct answer be? Yeah. Yeah, so the first element of the answers array would be the correct answer. And so that's not so, that wouldn't be something we need to store. But what would be a useful thing to store then? Yeah. That's sort of outside of the realm of the question. So, what do we do when we display a question? Do we just print the text of the question and then print the 4 answers in the same order we got them? No, we permuted the answers. So maybe we should say, there's this final thing, which the question will make up is the permutation of the answers. Okay, we called that P before. And so, and P, if we look at it, we got P by saying, P was a range, and then we shuffled it. So, range. It's a range with 4 elements, and we say random.shuffle self.permutation. Okay. So now we created a permutation of the we just created a permutation. It's not of anything yet, but we have this permutation that we're going to use when we display the question. So we'll use it to twist the answers around, not display them in the same order they were given. And then we can also, once we do that, then we can figure out where the correct answer is, because the correct answer will be the element of that permutation that has a 0 in it. So it's the first possible answer. All right, so what kind of things should a question be able to do?
Ask the question.
So ask the question, or maybe it should be able to, so the way you ask a question is in some sense to print it or display it, right? So we could say, there's different ways to do this, but we could say, let's define the string method for this question, which should return a string which looks like the way the question should be printed. So, when asking a question, what's the first thing we do? Well, maybe we should quickly play this game so that we remind ourselves what happens here. So what's the answer there, by the way? Submarine? Correct. Did you really know that?
Wait, how do we already have a score?
So what's the Bob Seger, Eric Clapton, Bob Dylan. Correct. Seasons in the Sun was from which band?
One.
Correct. Which actor played John McClane in Die Hard? Come on. You guys know this because Die Hard 5 was just aired recently, or 6 or 7 or whatever the number was. Golden hit for Neil Young. Wow, we're doing great. Evil Manta is a character from which animated film? Somebody with authority said Bug's Life, but that was wrong. It was The Little Mermaid. If you peg out, which game are you playing? Cribbage. Wow, we're doing really well. This is the best we've ever done. Who directed Breakfast at Tiffany's? It was not Woody Allen, and it was not Alfred Hitchcock, I'm pretty sure. Blake Edwards? Someone is using the internet. Which Spice Girl comes from Leeds? What's a Spice Girl? Which of the following was not a character in Pocahontas? Wiggins? Wrong. Grandfather Willow. Sean Moore and Nicky Jones are members of which band? 3. Wrong. Manic Street Preachers. Anyway, that's pretty good. We made it to 16 points. And now we remember how the game works. So if we're going to display a question, what kinds of things do we display? Yeah, so it seems like we wanted, the category, or I don't know, maybe we should just say, we'll call this thing Print Yourself. It'll be a little bit easier for us. So what we printed was the category. In fact, maybe we can just steal this code from somewhere else. Okay, you print the category. And now, instead of these weird numbers, Q at 6, Q at 5, we have nice things to put here. Self.category. Self.difficulty. Oh, D. Of course, these things are harder to spell than. Now we want to print the text of the question. And now we want to print all the possible answers. So, something like that. Okay. So this is how we'll print this thing. It's basically just code that we stole from somewhere else.
Sir,
Yep.
we want to change the applicant and the proposal to like D instead of that because we changed
Yes, you're right. Good catch. So the difficulty is an integer, so we should format it as an integer. Okay. All right. So now we can maybe start using this thing. Well, what else might we want from a question? No. What's a useful piece of information if we're going to make a game around this question? Maybe knowing what the correct answer is. So we could ask for correct answer, which should return the correct answer. Now, the question stores the answers in an array whose indices are 0, 1, 2, and 3. So we'll just return the index of the correct answer. And it'll be up to, well, if we want to be really lazy, we can just not do any shifting of indices. So we'll just return the index of the correct answer. So here's a puzzle for you. Where is the correct answer? Where does it get printed? What tells us where the correct answer is? Yeah. So the correct answer is the first element, the 0th element in this list of answers. But when we print the question, when does that get printed? Yeah.
Wherever 0 is in permutation.
Yeah. So it's in this permutation. Whenever this permutation is equal to 0, well, that's the correct answer. So it's the index of 0 in that permutation. And I think that means we can just say self.permutation.index of 0. And something we didn't fix is this should be self.answers at self.permutation. Okay? So now we have a question that can print itself. We can ask it what the correct answer is, and that's great. So now we just need to start using these questions. So we read this list of raw questions, and we'd like this to be a little bit, so these raw questions were basically an array of arrays. So we'd like to fix that a little bit better. Now, the real list of questions we get by taking, we want to create a question for everything in here. So let's call this A at 0, A at 1 through 5, A at 5, A at 6, for A in raw questions. Okay, so these raw questions were this array of arrays. So this was this list where each element of the list was the 6-part question or the 7-part question. Now we want to take each one of those lines and convert it into a real question. So the first part of the thing is the text of the question. The second part are the 4 possible answers. So we slice that. We take a slice from indices 1 through 4. Then the category, and then the difficulty. And something we did here was then we sorted the questions into the 3 difficulty levels, where questions at I is equal to Q in real questions if Q dot difficulty equals I. Okay, good. So let's see what else we need to change here. We don't need to make this permutation anymore. It gets made when we read the question. So that goes away. Difficulty we still need to compute. The question, again, is we take a random choice from the list of questions at the level of difficulty we're interested in. And now we don't call ask questions. We say Q, print yourself. Then we read the answer, and to check if it's the correct answer, we say if Q dot, let's say, answer is equal to Q dot correct answer. Then we say this is correct. Otherwise, we say that it's wrong. And I think we should be okay there. So that was a lot of code to write without testing. My guess is that we'll hit some snag, but let's try. Okay, something a little bit off there. There's the question. Something a little bit funny there, right? Well, actually, no, it's not wrong. It just looks funny. So what's the answer? Wow, that's super confusing. The worst possible question. Okay, so we got an error here that says question object does not support indexing. And that's because we missed a bit of code here where we tried to look at Q at 1. So we were supposed to print the correct answer. So what we could have done is Q dot answers at 0. Okay, who sang the Bond theme song, Live and Let Die? Wings? Correct. Who sang the Bond theme song, GoldenEye? Well, let's try Sheryl Crow because it's going to expose a problem to us. It says that's an invalid input. So we switched from 1-based indexing in these answers to 0-based indexing, but we never revisited our read answer method, which only accepts inputs 1, 2, 3, or 4. So we could either switch back to 1-based indexing or just allow this thing to accept 0s, but not 4s. So let's try again. Which year is a Prince album? Or the artist formerly known as Prince, now known as Prince again?
W.
W. Really? You guys don't know this? Tonight we're going to party like it's... Title of the Beatles' first #1 hit album. I would guess Help or Hard Day's Night. Wrong, it was From Me to You, not what I would have guessed. Stevie Wonder and Michael Jackson have both recorded duets with which former Beatle? I doubt that. Paul McCartney. All right, this one we know or we don't know. We've seen the answer. Option 2. With which series of films do you associate the phrase "ooh, matron"? I would guess Wayne's World, but I'm wrong. Carry on. We didn't do so well on this round. Okay, so so there we managed to do some apply some of this object-oriented programming principles, fairly basic ones, to this particular application. Is it a little bit easier or simpler? Some of it is a little bit simpler and more understandable now, code-wise. The stuff that cares about the format of the file, for instance, is all basically restricted to this point, to this code here. Once we get past this point, it didn't matter what format the file was in. We now have our thing stored in a question where the parts of the question have really meaningful names. Like here, when we sorted by difficulty, it was a meaningful name. The question can print itself. We don't have to know internally what it looks like. We can ask what its correct answer was rather than pulling a trick of checking if the permutation at some place is equal to 1. So it's arguably a little bit cleaner, though not shorter for sure. So then this next assignment basically has you doing something like this with a music collection where you read a bunch of stuff from a file which is supposed to be a collection of songs, and you do a couple of things. You load those into objects. One type of object is a track, which represents a single song, and another type of object is an album, which represents a collection of songs. And then you build an application around this. So that's your next assignment. I can tell you that historically, this assignment is the worst one of the course. This is the one that people struggle with the most. I have tried to make it a little bit simpler this time. In the past, there was not a file that contained this list of tracks that you read. There was actually a bunch of MP3 files, and people had to run over the disk, scanning these MP3 files, using a library to read the track names off the MP3 headers. So I've ditched that and just given you a CSV file. So that was the cause of some of the problems. But there are other problems as well, including, problems with equality versus identity that people will have difficulty with, and problems really knowing how to define objects this way. So this is your template where we really needed to define a fairly simple kind of object that when you initialize it, all its parts are known, and then you maybe have a few questions you ask of that object, or maybe you just use its properties in your application. Okay, so any questions so far? Good. So let's go back to this person class. So somewhere we had drawn a picture, I think it's gone now, of persons and other things. So we said there are, where'd they go? There's this class of thing called a person that has a first name and a last name. And then there's this thing called a musician. And a musician has an instrument that the musician plays. But it also has, musicians also has a first name and last name. And then there's another kind of thing called an employee that has an employee number, and it has first name and last name as well. So suppose we have an application, and for some reason our application has all of these things in it. So what kind of objects then would we have? And what's the relationship between these two things? Or these three things? So we have this person class, we've already made it, that contains its first name and its last name. What if we also wanted to have a musician class?
It would have to be a subclass.
Yeah. So something interesting is that everything that a person has, a musician also has. And that's because a musician is really a special kind of person. Okay? So there's another sort of phrase in here where you have musician is a, this part is not so important, special kind of person. So that suggests that, there's this relationship, and maybe a musician should just somehow inherit everything from a person. So the way we'd write that is we would say there's this class called musician, and it has a superclass, and its superclass is person. So up here we didn't say it out loud, but all we said about person is that a person is a special kind of object. That's just because in object-oriented programming, everything is a special kind of object. So if there's nothing else, above it, you just say it's a kind of object. But a musician is a kind of person. Okay. So if I was going to create a musician, well, I might take first name, a last name, and an instrument as arguments. And I should save the instrument equals instrument. And I should also save the first name and the last name. But that's sort of the job of the person class to do. And there's a sort of a really funny syntax for this that I'm not really happy with, but I will show it to you. That's called the super syntax. And it has a funny way of writing it. So what I want to do now is I'm defining this musician class. A musician is a special kind of person. A person knows how to initialize itself if you give it a first name and last name, and I'd like to make use of that method. So the right way there's several wrong ways to do this in Python. The right way to do it is to use this mechanism called super. You'll notice that it's in a different color because it's a special keyword in Python. You specify the name of the class that you're defining, self as an argument, and then you call the init method that you want to call. Okay. All right. So now we've got a class called a musician, and let's see what this class can do. So to create a musician, I specify three things: a first name, a last name, and an instrument.
What's a saxophone?
It's the instrument that I play, the saxophone. So, okay, good. All right, let's take a look at this musician that we've created. Well, it says it's a person, Pat Morin. So first of all, that's already weird because we never defined anything for converting this thing into a string in any way. We can try and convert this thing into a string, and it says it's, again, a person, Pat Morin. So where is this representation coming from? Why is it displaying it this way? So the musician class here doesn't have any of these things. Yeah.
Is that representation when you wrote up there?
Yeah. So we can even say we can even call this pretty print method, which is definitely not something that's in musician. And we get the same thing that we would get if we pretty printed a person. So this is called inheritance. And it's where a lot of the power of object-oriented programming comes from. So basically, we defined a special kind of person, a musician, that has a little bit more information associated with it. And with these few lines of code, we've suddenly got this object that can do all the things that a person can do. So anything that a person can do, this thing can do already for free. We don't have to redefine it unless we want to. It can pretty much do all of those, well, it can definitely do all of those things that a person can already do. And, that includes testing for equality. So I have Pat and I have Patrick. Pat is actually a musician. Is he equal to Patrick? Well, let's reason through it. What happens when I do this equality thing? What happens to the objects involved? It calls their underscore equal method. So Pat is a musician. Does he have an underscore equal method? Yeah. Yeah, so Pat and this musician inherits everything from person, including this underscore equal method. Well, this method looks at the left side, that's self, and checks if the first name on the left-hand side is equal to the first name on the right-hand side, and it checks if the last name on the left-hand side is equal to the last name on the right-hand side, and if both of those things are true, it returns true, otherwise it returns false. So what do you deduce from this? What's going to happen? True. They both have the same first name and last name, so they'll return true, even though they're very different things. One is a musician. I mean, they're not even the same kind of object anymore, although they're, both persons. Okay. Well, so now we can do all kinds of things. We also said that we had employees. So an employee doesn't have an instrument, they have an employee number. Okay, so let's make a musician named Pat Moran. Oops. Of course, he has to have an instrument, which is his saxophone. That's the super cool musician named Pat. And then there's the straight, uptight suit of an employee named, also named Pat Moran. His employee number is 999-999. So this should have been employee. I pasted the mistake again. Okay, so now I have a musician named Pat and an employee named Patrick. Do you think that they're equal? Yes. And why are they equal? Well, because when I ask if they're equal, that calls the underscore equal method. Neither of them actually define that method, so it ends up using the one in person, which works if their first name and last name are the same. Yeah. Which variable? Well, I defined it here. So as this argument, I defined it. Yeah. So, depending on your application, this may be exactly the behavior that you want. That if two, persons have different roles, they might appear in different ways. Like, I might be a musician, so I appear in some database as a musician, and I may be an employee, so I appear in some database as an employee. And saying that, well, these two things are equal, that may be the right thing to do because it's the same person, possibly. Yeah. Okay. Another equals method in employee. All right, so let's say, let's do something really crazy and return false. Okay. So what do you think is going to happen? True. And now what's going to happen? False. So it's easy, if you're not careful, to write an equality method that is not symmetric. So, and that's just because, remember the way that this is implemented. This is easy to read. It looks like you're asking if Patrick is equal to Pat, but that just gets turned into Patrick dot underscore equals Pat. So it's calling Patrick's, the employee's equal method, which returns false all the time. And if I do it the other way, it's asking if Pat is equal to Patrick. Don't ever do something like this. I mean, this is terrible. So you wouldn't want to do that. But now you know exactly how it works and what to expect when you do something like this. So I think that's probably a good place to leave it for now.